Hello, good people. So in this video again, I'm interested in showing you a very simple concept, which is trying to understand the unit circle. Understanding the unit circle. So once we understand the unit circle, then it means that we'll be able to answer different kind of questions under trigonometry. So we'll talk of how to draw the graphs for sine, cosine, and tangent. The unit circle will guide us on that. And also how to solve the trigonometric equation. The unit circle will guide us on that. It is very important for you to understand. So let's begin. What is the unit circle? We are simply saying a unit circle is a circle that helps us understand how angles and coordinates are connected. Now, remember we looked at angles and coordinates in the previous video. In the previous video, we looked at how angles and coordinates are connected in terms of trigonometry. We were able to find the coordinates of special angles, and so unit circle will help us as well in this area. So the key points to know on the unit circle. These points are very important. So I would advise you to make sure that you know them, master them, so that you don't forget. For example, we start with the point number 1, 0. This is the coordinate which corresponds to 0 degrees angle or 0 radians. Now, 1, 0, in the previous video, we looked at it by simply trying to understand the relationship between cos theta, sine theta in terms of coordinates. And then we know that when cos is 1, sine is 0. We looked at that in the previous video. So I would advise, if you haven't watched the previous video on understanding on how to find the ratios of the special angles and their coordinates, I would advise you to watch that. 0,1 corresponds to 90 degrees on the unit circle, or pi over 2 radians. -1,0 corresponds to 180. So 180, when cos represent x value. So when x is -1, then sine should be 0. And when x is -1, this is an angle of 180 degrees or pi radians. Then 0,-1 corresponds to 270. This is where y, or the sign, is negative. So this is very important. We shall demonstrate this on the diagram. So coordinates are given by simply saying we have this cos theta. This is just a reminder. We looked at this. Coordinates are given by cos theta, sine theta. So in other words, we are simply saying that cos theta, where we can say cos theta is equal to x. Cos theta is equal to x what? Coordinates. You can say x coordinates. And what about sine? Sine theta is equal to y coordinates. So this is very important for you to always remember. Don't forget this part, because if you do, you are going to face problems. So once we know this part, therefore now we need to come to the next stage, which is in the first quadrant. This quad simply stands for quadrant. We looked at quadrant, so I believe you understand what quadrants are. In the first quadrant, x is greater than 0 and y is greater than 0. This actually means, so let me say, this means x is positive. There is a positive value of x, and positive value of y. So in terms of coordinates, it simply means both of the values will be positive. But in the second quadrant, x is less than 0 and y is greater than 0. So this actually means that x will be negative x and y will be positive. And on the third quadrant, x is less than 0 and y is less than 0. This means that both of the coordinates are negative x and negative y. But on the fourth quadrant, we have x to be greater than 0 and y to be less than 0. So this means x is positive comma, y is negative. So these coordinates depend with the angle you are finding. So where you see they are negatives, just know that this is the angle not in the first quadrant, because in the first quadrant we know that all the ratios are positive, but in the second quadrant only the sign is positive, but the others are negative. So the concept that we in the previous videos is very important in order for you to be able to understand this. So now let's try to put this information in the unit circle diagram. So we are going to roughly draw the unit circle. Okay, don't mind my drawing. This is just try to help you understand. So the unit circle diagram, here it comes. So this is a unit circle. In the unit circle, according to the information that we have been given here, we can interpret it in this manner. We have 0 degrees there, we have 90 degrees here, we have 180 degrees, and 270 degrees. So this means that angles in between, angles in the first quadrant, okay, angles in the first quadrant are positive angles, okay. So what the first statement was saying that 0, 1 correspond to 0 degrees or 0 quadrant. We are simply saying the point at the unit circle here, from the origin, which is here, origin which is 0, to this point, the coordinates or the point, it is always 1, 0. Okay, 1, 0. So this is the coordinate for point at the center, for the point at the 0 degrees here. Then we move on to the second one, which is 0, 1, correspond to 90 degrees. So when you move along this circle, where we'll have another point here, this at 90 degrees, this is same as 0, 1. Okay, 0, 1 there. And when you continue moving on this unit circle, when you reach here at 180, this point here, we looked at it to be -1, 0. We can see that this is the x-axis and x is the negative. So it will be -1, 0. And when we continue moving here, we will reach at the point where y is negative. We can see that y is negative in this side. This point, y is negative, and also x is also negative. So this is where we have the coordinates, which was x is equal to 0, so 0, -1. Okay, remember in if you looked at some other concepts in inequalities, we looked at a point where saying lines that run from north to south are called x lines, and lines that run from east to west are called y lines. And always the whole of this line, which is the y-axis, is actually x is equal to 0. And the whole of this line is actually y is equal to 0. That is why we have 0, -x. If we reach at this point here, we have x is 0, y is -1. So we have the complete revolution or circle of this point. So it means that we can still find any other angle in between as long as it is in this unit circle. So let's say that we want to find this point, which we know that from 0 to these special angles, we can have a 30 degrees angle there. There's a point there, and we call this point, find the point which is x, y. Or we can say cos theta, sine theta. Okay. So for us to find this point here, all we need to do is to draw the terminal line, which is a terminal ray. We draw it like that, and then we show this relationship. So we are going to have a triangle, which of course is asking us to find the angle theta there. Now we know very well that in this relationship, we have what we call the length from the origin to 0 degrees. It is our x. It is on the x-axis, so it will be x. Then the vertical line, this side, it will be our y, and this side will be our radius. Hence we have, in order for us to find the coordinate x, y, we follow this relationship x, y. So we need to know the value which is here to there and the value which is there to there. So once we know the value, therefore we just replace and find our coordinates, and we are done. But for now, I just want you to understand the part where we indicate these important points. So you can write it in the following. You can just say here we know that x is negative, comma, y is positive, and x is less than 0, y is greater than 0. In this relationship, we know that x is negative, comma, y is also negative. This simply means that x is less than 0 and y is less than 0 as well. But in this relationship, we know x is positive, y is negative. This simply means x is greater than 0 and y is less than 0. In this first quadrant, we know very well that everything is positive. So x comma y, x is greater than 0 and y is greater than 0. So this is how you can represent it in the unit circle to help you remember very well. As if this is not enough, now let's look at this triangle in a very, very deep way in order for us to solve the question. So let's draw another unit circle this side. So I'm going to draw the unit circle, my rough unit circle. Don't mind my drawing. So this unit circle we have drawn here, we are going to put the angles 90, 0 degrees, 180, and 270 there. But you have to understand that in between these, there are special angles. We are talking of 30, we're talking of 30 degrees, we are talking of 45 degrees, we are talking of 60 degrees, then we have our 90 degrees. So this repeats itself. Even this side, it is one and the same. Okay, even this side is one and the same, even this side is one and the same. We have these special angles. So these special angles, we are going to use them in a very good way. So let's try to find the important angle now. Angle 30, this angle here. How can we find this angle? Or what is the ratio for us to find angle 30? We looked at that, but in this scenario, I just want us to use the triangles. Okay, so we have this triangle. Now we need to find this angle. We know is angle 30 degrees. So in representation of this lesson, I would expect you to be able to solve the point. You see where this point is here. This is angle 30, but they'll ask you to give us the coordinates of this point here, where angle 30 is. Okay, so how you find the coordinates, it is always x, comma, y. On this side, x comma what? Y. And this length from here, origin to this point, is what we call the radius. We can call it the radius or the length as it calls. So once we have this part, we need to know the following concepts. The length from here, this line, is actually called the terminal point. This is called the terminal ray, or you can call it, terminal ray. Okay? This is a terminal ray, this line. From here to there, it is a terminal ray. And this angle, which is formulated here, this angle 30, this sometimes it can be theta there. It is what we call the reference angle, the reference angle. So you may be asking yourself, why are we now talking of the terminal and the reference angle? I want you to know this because we are going now to be asked to find a different angle than these special angles which are here. So you need to know where to put the terminal point and what reference angle they are talking about. Okay, so with this knowledge, we are going to continue now finding trying to find the other angle. Let's say, for instance, we want to find this point which is here. Okay, we want to find this point which is here. We cannot draw our triangle touching the y-axis. The triangle should always touch the x-axis. So the terminal ray, it is simply giving us an angle between this terminal ray and the x-axis. Okay, so this is what you should always remember. So in our understanding, this point from here to there, it is our x value, and from here to this point, it is our y value. Remember, the ratios are well known, but let me just remind you of the ratios now. So the ratios will be sine. Okay, we start with the first part, sine. It will be sine theta. Sine theta is same as sine is opposite over hypotenuse. So when you look at this angle, opposite is y, so we have y over hypotenuse, which is r, and cos theta, we can look also with this side. Cos theta, we are simply talking of adjacent over hypotenuse. So these two is our r, so which will be adjacent is x over hypotenuse, which is r. Then tan theta is same as, what is tan theta? Tan theta is adjacent over opposite over adjacent. So we have x over y. So this is the relationship of these ratios to these triangles we are drawing there. So in other case, if you want to find the coordinates, okay, the coordinates for this, we are simply saying that if we have the relationship y comma r, the coordinates for this point, which is set there, it will simply be y, which is our x value is y. What will be our x value here? It will be x comma y. That will be our x value. So x comma y, this will be the point here, x comma y. Same applies with this one, x comma y. So if we have a number, let's say we have a number here, the number is 2. If we have a number, we say, let me draw another triangle here. We have this representation, which comes like that. We have 90 degrees. This is our radius. This is our x, and this is our y. Then x, they tell us, is -1, and y is 2. What would be the coordinates for this point? So the coordinates for this point, it is always x comma y. So it will be -1 comma 2. So this is the coordinate for this point. This is how you find this point. Okay, but the important thing that you need to know, how now do I find this r, this ratio? This comes from the Pythagoras theorem, which we looked at. So the formula that you need to always know, formula, let me just write it here. Formula for r, or we can call it length, is r is equal to x squared plus y squared. Okay, square root them. This comes from the relationship of a Pythagoras theorem, which is x squared plus y squared, like this. So in order for you to find the answer for r, you just have to use this concept and you'll be able to find the value for r. If you want to find the value of y, the value of x, this is the concept to use as well. You should find them correctly. Okay, so with this knowledge now, I expect you to be able to answer the following question. Let's look at the first example of this question. So the first example of this question is, okay, let's write the example for this question. The example for this question is saying in the diagram below. So example, in the diagram below, okay, in the diagram below, P has coordinates. P has coordinates. We are saying P has coordinates 12, 5. Find the values of sine angle XOP, cos angle XOP, and tan angle XOP. So what is the diagram looks like? The diagram is as follows. This is the diagram. They tell us that this is point P there, and we are told this is 5, and this is 12, and this is R there, and this is x-axis, and this is our y-axis, and this is 0. We can call it O. So the question is, we need to be able to find now sine XOP. So XOP, they are talking of this angle which is here. So we need to find this angle. So how do we find this angle? It is very simple. If you know the ratios, what ratios? If you know these ratios, then to find any angle, if you are given, for instance, we are told to find this is sine. Sine is opposite over hypotenuse, so it will be y over r. Simple. So we move on to solutions. So let's do the solutions just here. Solutions. Look at this. We know the ratio for sine. So sine of x or p is same as, what is the relationship? This is the angle we are trying to find here. It is always opposite over hypotenuse. So opposite over hypotenuse, it was y over r, which in this case we can replace. What is the value of y is 5. What is the value of r is, we don't know. So we just write it like that. So if we don't know the value of r, we need to find it in order for us to be able to find the sine, which is here. Okay, so how do we find the value of r? We remember the concept, which is simply say r is equal to x squared plus y squared. We square root them. So in this case, we are going to say, what is my x value? X value is 12. So we are going to say 12 squared plus, what is my y value? Is 5 squared. Square root this. Then we continue. 12 squared, this is 144 plus 25. 144 plus 25, this will give us 169. Okay, so once we have our 169, what is the square root of 169? Is 13. So the value of r is 13. So all you need to do now is to come and say sine of angle x or p is equal to 5 over 13. This will be your answer in paper 1. Okay, so this will be your answer in paper 1. You don't have to actually find the degree angle. No, you just have to end here, because in order for you to find the degree angle, you need to know what we call sine inverse, and you need a calculator. So in this case, we just end it here as your final answer, and you get it correct. So we do the same procedure now that we know our r, and we are told to find the cos and tan. Is one and the same. We just continue. We say cos of angle x or p is same as, what is the ratio? The ratio is x over r. Okay, what is x over r? We know what is our x. Our x is 12. So we are going to say 12 over r is 13. So this will be your answer. You end just there. And tan of x or p is same as, what is the ratio? X comma y. So what is the value of x? The value of x is 12. So we write 12 is equal to, what is the value of y? 5. And we end here. So these are the correct answers. This is how you are going to leave your answers in paper 1. Okay, so in paper 1 you are done. But if it's in paper 2, you need now to come to write the inverse tan. For instance, if you want to find this one, tan inverse of 12, 5. By using a calculator, you can easily find this. By using a calculator, you can easily find the angle. What is the angle? The angle will be, we'll say, what is 12 divided by 5? We are going to have 2.5. Then we say shift there. And when we say shift and tan, we are going to have the inverse, you can see. Then we click equal to. Then the angle we are talking of, the tan, is 67.4. So this is going to be x or p is same as 67.4 degrees by using a calculator. But in paper 1, we leave it this way. In paper 2, this is where we can use the calculator to find the angle in this manner. Okay, hopefully I've made this video clear and easy for you. The next video will have a lot of questions that you need just to practice and solve, and I believe you'll be able to answer them without any problem. Now remember, this concept will help us now to be able to draw for sine, cosine, and tangent curves, to draw the graphs for these and also solve the trigonometric equations, and we can say we are done with trigonometry. Hopefully this video has made sense. Please pause the video, write down the notes and everything, so that in later time you can study and understand it better and better, and we make our future bright. Remember, mathematics is made easy by the online learning, and this can help you to achieve great results in any examination that you are given. Thank you for watching. Stay blessed. Bye bye.